Hi, everyone. My name is Ryan Boyd, and I'm here to quack at you today about fixing the data engineering lifecycle. I am a co-founder at a company called MotherDuck, and you can reach me on Twitter at RyGuyRG. Now, the ideal data engineering lifecycle. Well, what is that? If we look at the very popular book, Fundamentals of Data Engineering, an O'Reilly book published by Joe Reese and Matt Housley, they define data engineering as a structured journey that takes raw data and makes it into valuable end products. No, not just end products, but valuable end products. What we're producing needs to be valuable for the business. And we'd hope that the data engineering lifecycle would be, this straightforward, this linear. But in reality, the data engineering lifecycle might look like this, a semi-structured journey rather than a structured journey. And in the worst case, it might look like this, where you take 10 steps forward, but you then take 10 steps backwards as you try to go from your raw data to your end data products. So answer this question for yourself. Do you have data engineering life cycles that look like this, that are causing you these headaches? If you do, then maybe we should look at software engineering practices and see if that will improve your headaches or lessen them at least. So what do we as software engineers do in terms of what is our life cycle of building products, software products? And I'm going to show you here a typical life cycle around a open source project. Your mileage will vary at different companies, but typically we have a local development environment centered around an IDE like VS Code. We have a complete copy of our code running locally in Docker or local stack, etc. Lots of great tooling for this nowadays and great hardware. We store our code in a source code repository like Git, and we write tests that execute before our code is committed to the source code repository. And we really hope if we can apply these types of principles to give you a fast, iterative, local environment for development with testing infrastructure in place, with source code repositories in place, that we can make your data engineering lifecycle look more like this. Now, as you take the raw data and turn it into these valuable end products, you're going to go through a variety of different stages. You're going to do generation of your data, storage of your data, ingestion, transformation, and serving. And we really should be doing testing at each of these steps. Testing is one of the important parts, important things that we've learned in software engineering best practices. And for data engineering, we want to test after generating data, after storing data to make sure it's stored properly, make sure it's ingested properly, make sure it's transformed properly. And in fact, I missed one instance of testing here. You should also probably have testing on your end products, integration tests that run end to end and page you at 3 a.m. if something goes wrong. But hopefully you don't get that page because you've done all of the earlier work on testing. So testing is super important for software engineering to ensure the quality of the code that we're writing. And we need it to be important for data engineers too, to ensure that data quality is great and to ensure that we can iterate quickly on our data life cycles. So the modern data stack has made things more complex. It might have slowed down some things in the process. Testing will initially slow some things down as you write your tests, but then should hopefully make it possible for you to move much faster. And that's really what it does for software engineers. There are a whole variety of different types of tests. This is a diagram from Atlassian. With data engineering, I think we should focus really on unit testing and integration testing. Now, why wouldn't we do this testing? What are the objections to doing the testing? One of them is we don't have test and staging schemas. Well, I'm sorry. Really, I am sorry. This is rather frustrating, and you should fix this now. You've probably been meaning to for a while, have test and staging schemas or environments. But then sometimes other people come into play. So you have your test and staging environments in the cloud, but these are slow and they're expensive. I actually talked with someone at the DBT Coalesce conference recently who had a CFO demand that they take down the test and staging environments that they had in Snowflake because they were too expensive. So what are they to do? They don't have test and staging environments anymore. That's very unfortunate. But we have to ask ourselves is why are we relying on the cloud? Why are we relying on the cloud to do these environments? And while at the same time as we have these laptops sitting on our desk, my M1 Pro or M1 Max here is 2 generations old, but it has 32 gigabytes of RAM, it has 10 cores, and it sits 85% idle. But some people say since production is a cloud service, we can't run a local version. Well, I'd beg to differ. I think with the latest technology nowadays, it's really easy to run a local version. But you have to patch a few things together. So for instance, we can take DuckDB and run it locally, just the same as we could run a local Postgres instance if we're doing transactional data. And then, we might want to transpile our SQL so that it can go into production. And we might want to test and make sure that the data is the same that is produced between local and production. And so we end up with a lifecycle that looks like this. We have a local Git repo, and that local Git repo stores all of our models and all of our SQL queries. It breaks it up into profiles, maybe, for our different stages. And we have maybe a local Airbyte instance that pulls in data, but maybe not quite as much data as in production. And we have tests that run locally. Now, most DBT tests are on the models and sort of integration tests, but DBT is actually working hard on unit tests. This is one of the top features in their roadmap today, and they are building the ability for you to do unit tests within DBT. So look forward to that. And, once you have testing, you can then also have your transpiling of your SQL. So basically, SQL will convert your SQL that you're working on for DuckDB into SQL that will work well in other environments, say Snowflake. And you can do that and then run your data diff. So data diff is a tool that will just compare the data sets that exist in multiple environments. Now, you might want to compare your local to your staging to your production, or you might just want to, have local environment have a small subset of the data where you can still compare that. But you can also then compare staging and production and make sure that those two, even if they're in the cloud, are identical in terms of the data that exists. Then what do we do? After we compare, everything looks good, we can commit, we can push, we can have our automated builds, and we can be in our staging environment. This is very similar to what software engineers do every day. They're developing locally, they're testing locally, they're submitting their code. The tests probably run again in their build environment, and then they can push to their staging environment. Now, you still might object to this. You might say, hey, transpiling SQL is dangerous, so we can't just test. QED. Well, for those of you that say that, there is actually a solution. And the solution really is to run the same database that you're running locally as the database that you're running in the cloud. And this is possible. This has been possible to some degree with some other databases. They've tried to make a local executable version, but with DuckDB being so lightweight as a 20 megabyte executable, DuckDB can run locally and in the cloud and provide the ability to do no SQL transpilation, no schema changes, et cetera, between your local and your staging and prod environments. Now, I'd like to acknowledge some of the people who I've worked with on these challenges and have been kind of thought partners here. Winnie and Mehdi and Matt Housley and Joe Reese and Sungwon Chung. They all participated in a panel at Coalesce called Fixing the Data Eng Lifecycle, hosted by Luis here. I'd encourage you all to check that out if you want to dive into this more. So now we're going to stop quacking and let you get querying. Thanks, everyone.